Hello, everybody. Let me get my microphone over here a little better. There we go. You can see it right there. Look right there, bro. It's right here. Oh, look. Oh. Anyway, hey, whew, mm, man, been a couple days since we did one of these live ones. We're on lesson number 19 already. Today we're going to be talking about inverse operations involving groups. Some stuff that's a little uncommon. Sometimes you have to distribute, sometimes you have to divide, all kinds of stuff like that. Especially what to do if you have something that's unknown in the denominator of a fraction. We're going to be talking about all that. It's going to be awesome. But as always, learning, it's not a passive activity. It requires active engagement. That means you need to be taking notes, writing questions, thinking, challenging your understanding, all that kind of happiness. Let's get into it. Check this out. Inverse operations involving groups like these three right here. You should be able to solve all three of these today. No problem. Now, they're all three different. This is actually a group right here, the denominator. But, yeah, anyway, let's get into it. So check this one out right here. There's a couple ways that you can see something like this. You might also see something like this where, say, it said x plus 2 equals 18. So check this out. This is idea number one right here. These two are idea number one. So here's the big idea with idea number one. You see, when we're solving, first of all, when you're solving for x, what you're doing is you're looking for a value that makes a statement true. And we use that idea extensively when we were doing the box method. Like we did this, one half of what is 5? Well, this has to be 10, right? So one half of what is 5? This is the thing we don't know. So half times what is 5? Well, that has to be 10, so then x is 8, right? But let's say it was a little, well, let me put it this way. What if this was a little bit more complicated than that? Like you couldn't just figure it out by saying, by reading it and then filling in the gap, right? What would you be able to do? Both of these are that kind of situation where the thing we're solving for, the x is inside the parentheses, and you're done when you have x equals a number, and that x makes the statement true. So here is 8. 8 plus 2 is 10. 10 times 1 half is 5, right? But let's talk about another way to figure that out. So you got two options here. You see how this 1 half is, this 1 half is multiplying times everything in the group. That's what makes these parentheses necessary. You see? If it was 1 half x plus 2 equals 5, that's a totally different kind of problem. The x is no longer in a group. You can just use plain old plain old inverse operations, right? But this plus 2 doesn't go here first. It goes last. When you're doing inverse operations, you're going backwards. So what we can do is two options. We could either distribute and multiply that number outside to everything inside, or we can divide. So here's what would make me decide. You see how, well, let's look at this one first. You see this 6 goes into the 18? So I want to distribute. I would actually divide. I would divide that one. So like x plus 2 equals 18. So I'd actually divide both sides by 6, do you see? And those 6's disappear. Because, well, they make 1, right? You don't need to write times 1. What plus 2 is 3? X equals 1. Now we can plug that in right here. 1 plus 2 is 3. 3 times 6 is 18. Boom, we're done. That works just fine and dandy, right? Now, here's where you got to be a little bit careful. What if it said something like this? Ooh, now, you see, now that's a little different. Dang. In fact, I'm going to make this a 4 so our numbers work out a little easier. So here it says 6 times x plus 2 plus 4 equals 18. So this one's a little different because you see this 4 is not in the group. And if we look at our order of operations up here, addition and subtraction go first, second, third, last. So here you would actually have to subtract 4 from both sides first. And you'd get 14. Oh, it didn't even work anyway. I should have done 6. Anyway, it doesn't work, so then you divide by 6. 14 over 6 is the same as 7 over 3. Subtracting 2, see, 6 over 3 is 2. X is 1/3. But let's look at this one now. You have two choices. You can distribute, or you can multiply. You can divide. You can divide both sides, or, you know. So what I would do is I'd multiply both sides by 2 over 1. I'd get x plus 2 equals 10. So x equals 8. See how we did that? Dang. Man, no problems there, right? Okay. So, big idea. Check this out. Here's idea number one. Here's where we're going to come back to this page in just a second. But if you've got something like this, or you have something like this, they're almost the same problem. Do you see how the 8 is not divisible by 5? So in this case, I would distribute. Whereas in this case, I would divide both sides by 4 because 4 goes into 8. You don't have a fraction. So this one would be 5x plus 15 equals 8. And this one would be x plus 3 equals 2. That'd be your next step. And from there, now it's just pretty simple. Basic inverse operations. Subtract, divide, boom, done. All right. On to idea number 2. What do you do if you're trying to solve for x and the denominator contains the x? It's actually in a group right there. So it's almost always going to work out this way, the same every time. You can't solve for x when it's in the denominator. You have to get it out of the denominator. So the way we're going to do that is we're going to multiply both sides. You see, like this. Because those make 1, you're left with 8 equals x squared. Boom, done. Now, we're not done solving for x. This square, the inverse of square, is square root. So we have square root of 8 equals x. That's not simplified. It's 2 root 2. You might need to go back a couple weeks to figure that out if you forgot it, but that's how that one works right there. So the idea with number 2 is that if you have an unknown in the denominator, like let's say we had 5 divided by x minus 2 equals, I don't know, let's say it's 15. Let's say it was 3, right? Let's see, like this right here. Now we could actually figure this one out because 15 divided by what is 3? Well, this has to be 5, right? That has to be a 5. So that means x is 7 because 7 minus 2 is 5. But let's say we couldn't figure that out. Let's say we could not figure that out. So what we would have to do to get this out of the denominators, we'd have to multiply both sides by x minus 2. Now here's the thing. X minus 2 is a group. So it reduces with itself. 15 equals 3x minus 6. Or you could have divided both sides by 3 from there anyway. And then, add. So that's 21 equals 3x. And just like we said, 7 is x. Because what times 3 is 21? 7. So, second big idea. If the unknown's in the denominator, multiply both sides by that denominator to get it bye-bye so that you can have, so it's no longer in the denominator, then you can isolate it. Now this one right here, this is a little tricky. Excuse me. What cubed is 8? Well, I think 2 cubed is 8. Is that right? 2 cubed is 8, right? Because like 2 cubed is 8. That's true. 2 cubed is 8. So this whole thing has to equal 2. So I think x is going to be 3 because 3 minus 1 is 2. But let's say couldn't figure that out in your head, or let's say maybe it wasn't something you could figure out in your head at all, no matter if you had the math fact or not. The opposite of cube is cube root, which is the same as the exponent of 1/3. So there's two ways you could write this. You could write it like this, your very first step, and you get x minus 1, because when you raise an exponent to another exponent, a power raised to power you multiply, 3 times 1/3 is 1. So it would really be like that, but you just write x minus 1. And then what cubed is 3, or what cubed is 2 is I said the answer. What cubed is 8? What cubed is 8? What cubed is 8? The answer is 2. There you go. Another way you could write it. Let's start over. Right? We got that hotness right there. Another way you can write it is with cube root this way, with the cube in the index. You may or may not know that. I don't really, it doesn't really matter, but this is saying we're looking for a number that's cubed. Well, this is the number that's cubed, and then the number cubed that is equal to 8 is 2. So either way, we got it. So anyway, let's recap, right? If you have, first idea, if you have your unknown in a group, like parentheses, and there's a coefficient, well, you've got two choices. You can either distribute or you can divide. The best way to make the decision is if you divide, does that number go into the number on the other side evenly or not? And also, this is a little different because, remember, if it was like this, you can't divide, if you divided this by 4, you'd have to divide everything on both sides by 4. Do you see? So don't do that right away. Make sure you get this thing right here isolated using inverse operations first, okay? So, big idea. Either you can distribute or you can divide. It depends on if that coefficient divides evenly into the other side or not. You can get the right answer either way, but one way is easier than the other. Second idea, if your unknown is in the denominator, what you got to do is you got to multiply both sides by that denominator so it will no longer be in the denominator, and then you can use inverse operations from there to get it alone. Last idea is, say you've got an exponent that's keeping your group together. Like in our first idea, we had a coefficient, a number multiplying, that kept that group together. Now we've got an exponent keeping the group together. Well, you have to do like if it's a cube, you do cube root. If it's square, you do square root, things like that. So you just, yeah, you use your rules of exponents to make this into an exponent of 1. What you do to one side, you got to do the other, and then you can use inverse operations. You guys are killing it.